Most people think AI robots run on code, data, and electricity. But what if that's only half the truth? Because behind every smart machine, there's something unexpected. Gold, silver, hidden inside circuits you never see. So here's the real question. Are AI robots powered by intelligence or quietly dependent on ancient metals from the earth? AI is often shown as something invisible, cloud systems, digital brains, software thinking on its own. But reality is very different. Every AI system exists inside physical hardware, chips, sensors, circuits, robotic systems. And all of them depend on materials that don't fail under heat, pressure, and constant electricity. The problem is, most people never think about what those systems are actually made of. So here's the question. If AI is digital, why does it depend so heavily on physical metals from the ground? Because the truth is simple. No hardware means no AI. And no stable materials means no reliable intelligence. Inside AI processors, there are microscopic connections carrying billions of signals per second. What happens if even one connection fails? That's why gold is used in critical chip connections. Not because it's expensive, but because it doesn't corrode or break easily over time. Silver is one of the best conductors of electricity known. Why does speed and efficiency matter so much in AI systems? Because robots, servers, and sensors all depend on instant signal flow. Silver helps reduce resistance in high-performance circuits. Now, AI is no longer just phones and apps. What happens when AI becomes robotics, factories, vehicles, and infrastructure? Every system starts needing the same types of materials at massive scale. And that's where pressure begins to build quietly. AI grows in months and years, but mining grows in decades. Can physical resources actually match digital expansion? Because gold and silver cannot be scaled like software. They require extraction, processing, and global supply chains. AI is not the only system using these materials. What happens when multiple industries compete for the same resources? Electronics, energy systems, automotive, defense systems, all pulling from the same limited supply base. So how does the system respond? First, engineers try to reduce material usage. Then they redesign chips and systems for efficiency. Then they explore substitutes where possible. But here's the limitation. Can every high-performance system actually replace gold or silver without losing reliability? Not always. Some things simply cannot be replaced. So instead of disappearing, these materials often become more critical over time. So here's the final question. If AI keeps growing faster every year, but the materials behind it don't scale the same way, which means the system doesn't eliminate dependency, it manages it. What happens when those two worlds collide? Is the future of intelligence limited by code, or quietly shaped by what we can pull from the earth? Comment what you think below, and if you want more deep breakdowns like this, subscribe to Wealth Insure Lab for more updates.